All right. So we have actually already, since we did that survey yesterday, we've worked with a lot of these things. We just didn't have names for them yet. So we're going to give a whole lot of the things we did yesterday names, talk about what they meant, why we did that, why we cared. And then we're going to use that data in all kinds of activities all throughout the chapter. So all that data that you guys put into that survey, we're going to pull that in and use your actual data for a lot of the things we're going to use. So in order to do that, though, we need to be able to talk about stuff without me having to say you guys and all of the things that we measured. And all of those things, they have names. So we're going to give them all names. So our first one that we have is something called cases. And cases has a couple of synonyms. It could be our subjects. We can also call these our individuals. So for our survey yesterday, that was y'all. Y'all were our cases. It is who or what we wanted information about. So it could be that it was the people that we talked to. It could be if we're doing data analysis of like tools on a manufacturing plant. It could be the measurement of every wrench or the measurement of every bolt. It's who or what we want information about. Those are the cases. It's who we're looking to study. So then we have our variable that we're looking at. We've used variable before. We usually use that for things like letters in our equations. But when we're talking statistics, our variable is each piece of recorded information about the case. So our definition is each piece about a case. So if our cases are who we want to know information about, the variable is the information we want. So another way of wording that is what we are finding out or what we want to know. What we want to know is our variable. Just like in an equation, I'm usually solving for x. I want to know what x is. This is, I want to know what the average height of the people in class are, or the average length of your index finger, because that was the thing that we measured. Because, you know, reasons? I don't know, I didn't design it. And when we're gathering information, and when you guys put data into that website, there's really two different kinds of data we deal with. We deal with categorical data and we deal with quantitative data. So categorical data, if we think of the word categorical, what word do we see in categorical? Or what kind of word do we think might be related to categorical? Category. It divides them into categories. So categorical data divides cases into groups. Y'all good?
No.
Ooh, let me change. I'm going to rewrite that into groups because that got smushed. Or categories. It's things that have no in-betweens. Like, we could check a box. I could check that we liked superhero power of flying versus teleportation versus super speed, or whatever the options were. It was categories. There wasn't in-betweens. So things like if you were marking down your eye color, that's something that would be categorical. There's only so many options we can pick. According to like a survey, there's only so many options we can pick. There's not a way to quantitatively measure your eye color.
You could change the eye color into being the number.
If you did like hex code.
Yeah, you could do it like that way.
Or if we had
Or RGB.
what's that? Oh, hair texture would be categorical. Absolutely, that's a good one. Because that's something that you kind of would classify in buckets. There's another way to think of it. If I can put you into bins, think top, bin, like tops, pants, socks when you're short laundry. There's very rarely things that wind up in more than one bin. Tops, bottoms, socks, shoes. When we're talking things like age, that can even be categorical. Because if I say, how many of us in here are 17, I got a whole lot of answers, right?
No.
We can do age as a quantitative, and I'll talk about quantitative in just a second. But when it's just like people who are between the ages of 16 and 18, 19 and 25, 26 and 30, like those are categorical ways of marking down age. Because quantitative is a little bit different than categorical, is what we're thinking it. Quantitative versus categorical.
You know what I'm thinking.
I know. Quantitative. What word do we see in quantitative? Quantity. Very related.
Number.
It's numbered things. Things that there can be in-betweens of. We rounded to the nearest centimeter yesterday, but we didn't have to. We could have gone decimally and gross. So quantitative are things that we measure.
Like how many people took the survey?
Things like our height. Things like our weight. If we measured that, we didn't do that. Because ew.
Arm span.
Yeah. Our arm span, our weight, our height. You are absolutely determined for me to put the word weight up here. Oh my gosh.
Okay, Moses, what would it be in?
Height. I have agreed to wait about 6 times.
Wait. Let's see if you can answer this.
No.
What would it be in then? What we're doing weight?
Yeah.
No, I'm talking about like the measurement.
We didn't measure it.
In what measurement?
What unit are you talking?
Oh, unit? If we're doing like from the survey from yesterday.
Yeah.
But for that, it would be in
Would have been in kilograms. Because we did everything metric. But that's okay. We didn't take weight because, ew.
because it's going to be
No. Not bringing in the scale in. We're not putting our weights on the internet. Thank you. So the things that we measured, because I'm never going to come up here and say, all right, whose height measured exactly 147 centimeters? Because that'd be weird.
Well, you could. Yeah.
I mean, I could.
You could say.
We could sort it categorically, very much like how we did age, where it's everybody between 100 centimeters, which is very short, and 150 centimeters, and then people who are 150 centimeters to 200 centimeters. So we could divide them into categorical data sets, but usually our quantitative stuff we look at in different ways. So depending on the type of data we have, we're going to analyze it in different ways. So we're going to do a lot of things with quantitative data. We honestly focus mostly on quantitative data, but we do something with our categorical. And we'll talk about both of those as we go through them. But questions on these 4 words, really, as we are right now. So, and again, we're going to use all of these in a whole bunch of different times between now and like the first week in November, which is as long as this chapter goes. It's a big chapter.
The first week of November? Are we splitting it up?
Nope. Just say,
Pain and suffering.
yeah, November 8th is when this chapter ends. November 8th. So it's a big chapter. With a lot of things in it. Okay, let's look at the next table that we have here. These words should hopefully be somewhat familiar. You talked about these in Algebra 2.
You also took.
Not a while ago.
It's been a minute.
No, I haven't. Not for me.
I know.
Green, that's a
I know. That's why I tried to talk you out of this one to begin with.
It's just
the process of it is annoying. It's
Mhm.
a problem.
You say, you can look through the book. It's got lots and lots. But I'm gonna show you. We're gonna do a lot of it on software.
Yeah, it's not mostly stats.
You've got 8 more school days until fall break. I always keep that 8 school days. Weekends don't count because we're not in school. 8 school days.
So I'm like, wait, that
All right.
messes with my head for a minute.
School days, not weekend days. School days. All right. Back into this. So now we're going to talking about taking a sample and taking surveys. What we did yesterday was a survey. So we've got 4 words here that deal with surveys, and my turn to talk. 4 words that deal with surveys a lot here. And we've got our population, sample, parameter, and statistic. Population, sample, and statistic should be fairly familiar. Parameter, maybe not, because it's not used super commonly in like people talking. So population, what do we think population is? What do we think of when we hear the word population? People. Is it a small group of people or is it a big group of people?
Could be either.
Could be either. But more often than not, they are big group of people. It could be billions. What our population is in relation to our data here and our data and statistics, it's the entire group we want to know about. What are we hitting with our notebooks?
Try to hit a fly.
Oh, if you catch them, I'll give you some out of the treasure box.
Alright, let's go.
Without hitting anyone else.
It's on the window over there.
Just saying. Because he's been stuck in here for a week and a half and it drives me nuts. Okay.
It's over there.
So what our population is the entire group of people, or the entire group. Guys, it's my turn to talk and we should be writing.
2 flies. No.
I know there's 2 flies in here.
Step on
I
it.
got it. You ready? Where's it at?
It's right on the floor.
Yeah. I killed it.
It's right there.
Show me. Prove it. Prove it if you want me to get out treasure box. I was say, because I don't believe you. I don't believe you if you just say got it. Show me.
Huh?
Let's see if you got.
I was like, you guys show me. I mean, you don't need to act smush. Like, it's okay. I will handle it. Squirrely children, lock it back in.
Okay.
Oh my gosh. Squirrely. So squirrely today. Holy cow.
You want a little more squirrely though.
Lock it in. Thank you. So the population is the entire group we want to know about. That was a worldwide sample that was done with students. So our population for that survey we did yesterday was students from across the globe. They want to know about everybody. Sample, ooh, that's not a highlighter. The sample, we took a sample yesterday. What's that?
Yeah, it's gonna say it.
Okay, go for it.
It's a part of the population being dumbed down to a set number.
Yep.
Hands to yourself.
Our sample is a small portion of the population.
It's over 30 people is approximately normal. You know where I'm
Sean.
going with this? You know where I'm going with this, aren't you?
I know you're going way more in depth than we need to do. It's more practical to deal with. Oop.
Or you just put the in and see if anybody will know what it means.
No.
Aw, it's fun.
We use very few of the actual notational symbols. We'll use X bar, but that's it.
Well, still, you would need that to be normal.
We're not going to deal a whole lot with normal, except from describing the shape. We're not going to deal with normal distribution all that hard. All right. I really don't want to have to say lock it in after every single sentence, but I need you guys to bring it back in, please.
You just need like a honker.
I'm not going to get the elementary school doorbell system where you ding the doorbell and make it ding throughout the classroom.
Just like a clown horn.
I'm not going to do that. That would be more disruptive. Not helping, sir. I know, I can tell. All right. Statistics should be a familiar word because we hear about statistics a lot. You dealt with those in Algebra 2. Statistic is about the people we looked at. So the sample we took yesterday was our data. We were the sample. Our class's data. So the statistic that we get is the data analysis of our sample. It's the numbers we can calculate. It's the data analysis is the formal way to write it.
Let's look back here.
You don't need to. We're just mostly going to use the words. It's just that somebody designed this page, so we're just filling in the boxes. The design of the boxes is not particularly important. I don't know why they're shaped this way, but they are. It's better than just a blank page full of words, I guess. So I could go and pull our data and we could find the average height of people in this class. I can calculate it. I have the heights we all have. We could crunch those numbers. I could find it out. We will later, but we could find it out. The average height of people in this class.
It's gonna be 5'6".
Well, to be fair, it's gonna be in centimeters. So, but we can go and calculate that. The reason we collect that data and we use and find that statistic is so that I can make a prediction about my population. I'm not going to go to every school in the entire world and get everybody's height for every student in the entire world. That would take a logistical nightmare. That would be logistically so hard to do because time and every place on the world. And by the time I finished, the people who were seniors when I started will not be seniors anymore.
You would have to have people do it.
We would have to have people all around the world doing it all at the same time, and it's a logistical nightmare. So we physically wouldn't have a way to collect all this data for seniors across the globe and be able to do it while they were still seniors. Like, we'd get all kinds of different time ranges. So we take these samples so that I can collect the data when I'm intending to and use that to make an estimate about my population. That estimate about our population is called the parameter.
Then you do it.
I was going to say, arrange it. If you can arrange the funding, if you can arrange the transport, if you can arrange all that stuff, that can be arranged. Thank you. Awesome. No, it's not. It's mine. Literally, it has my name on it. Because it's a test for Algebra 2?
Well,
I can do that. I can work through break.
It's someone else's test.
I'll do it.
No, you will not.
Why not?
Yeah.
So it's the parameter is a prediction about the population based on our statistic, based on the data we collect. So the statistic is something we know, guaranteed, calculated, we can do this. We know this, we calculate it. We use this to make a prediction. We guess this. What are you talking about? Let's not take pictures of people's government IDs. That is questionable at best. I mean, it's
Don't
not.
have your government ID out, right?
All right. Keep your identifying information private, and let's not post. People that have Not a reportable offense. It's just a little weird. It's not against the rules. It's just weird.
Unless they claim to be invented.
Okay, so we're going to be looking at things like statistics and samples and using that, collecting a whole lot of data, and then analyzing it. So we're going to talk about some of the different ways we can analyze things. So on the next page, we're going to do the top table, and that's the only one. So I told you, this one was going to have a lot of writing here. So this one has a whole bunch of stuff. We're talking about measures of center. We're going to talk about measures of spread. And we're going to do 5 little sketchy sketches in the bottom for some ways things can be shaped. Basic. Basic shapes. Not my fault, man. All right. So we have, what's that? Yeah. We have some ways of measuring center, and you have worked with some. You may not have used the phrase measuring of the center, but you've done these. Because you started doing these, I think, 6th grade. You've done measures of center? You sure have. You just might not have used the word. So if I wanted to think about the middle, so if I talk about your guys' heights, and I wanted to find a way to describe everyone in his height without putting up a list, what might I do with all those heights? If I pull up that list, I've already mentioned it once, but I just didn't talk about why. How? How can I take... All right, I need you to stop talking over me. I need it stopped. This is a class you signed up for. Stop talking over me. So if I took our list of heights from yesterday, and I got our list, all 27 of them, because that's how many submissions I have right now, and I wanted to use that to make a prediction, what would I do with that list of heights? What could I do? If I wanted to smush it together and have it be one number. Would it make sense to add them all up? And just take like all you guys and stack them shoulder to shoulder to shoulder to shoulder to shoulder? How tall are we all combined?
Then divide. You must find
What would we do if I wanted to talk about, as a whole, we have a height kind of around... How can I find that out?
Add everything up to divide by the set number.
What's that called?
The mean.
The mean.
Mean.
Mean is one of our ways of measuring center. We'll talk. You're going to hold your tongue there for a second. What is another word for mean? Not mean and median are not the same thing, but good instinct. Hold that thought for another second. Average. How do we find a mean or an average?
Don't you add everything divided by the number of
Yeah. So we sum all values, add them all up. And then we divide by the number of values. So we calculate the mean by adding up all the heights and dividing by how many. So add them all together, divide by how many. So I could find the average height of people in this room. We could do that. I've used that as kind of our example on a lot of things, our average height. What is another way of marking center? When I said mean, you guys instantly said another word. Median. What does median mean?
Middle.
Think about when you're driving. Those concrete dudes in the middle of the road, what are those called? The median. They're in the middle. So median is in the middle. How are we going to find a median if I have a list of numbers? What do you think, Walter? Or are you just stretching? Yeah, we got to put them in order. Exactly. Put them in order, and it's the number in the middle. I mean, you can do that if you want to, but this is the easy way. We got to put them in order and then find the middle. So a lot of us, when we said mean and then median, we had one more word that popped into our head. What was that last word? Mode. What is the mode? What does the mode mean? So mean was our average. What's up, Walter? Okay, you're fine. It's the most common. Mode is most. It's the most common, the most repeated. So most common, most repeated. If we're looking at a graph, it would be the highest peak. Or our maximum. Most of the time. Then we're getting into more in-depth issues than we need right now.
It could also be lowest.
It could. Depending on how you're driving.
You're furthest away from your center there.
It's the most repeated. Oh, max. We're pretty much only going to see them when it's a maximum. You're getting into fancy schmanciness. Yeah. All right, so then we're going to talk about measures of spread, which is a way of describing not the middle, so our center describes where the middle is, but our measure of spread says how far away most people are from that middle. So if it's a really good center, everyone's going to be pretty close. So our average height, if everyone in here was pretty close together, like if you look at the Rockettes, the girls who dance for the Thanksgiving show right before the football game stuff, the Rockettes, their average height is really similar because they have to be between 5'9" and 5'11" to be in the dance group. Like their average height is real close together. So their center is going to be right at that 5'10", and their spread's going to be really small. They're going to be real close together. Whereas if we look at a very small school where they have kindergartners through seniors, K through 12 school, the average height of students in that building is going to be a lot bigger. So their center will probably be right around 6th graders. And then there's a whole lot of difference in height on there. Okay, so there's a much bigger spread in the school than there is in the dance troupe. So our two ways of measuring that, and we'll talk in more detail about what we do with each of these, is our range, which we might remember the word range. And this is our greatest minus our least. So it's how far apart the highest person is from the lowest person. We're going to use something called quartiles.
Which we might have seen in IQRs.
Yes, and that's exactly what we would be talking about is IQR. And what this is it takes our data and cuts it into 4 pieces. Quartiles is actually quarters. It's just a super mathy way of saying quarters.
No, that's been defined.
No, it doesn't. No.
No, the quartiles does.
There's 5 numbers, but it's dividing your data into 4 sections.
Okay. Like, you're dividing it into 4, like,
It's 4 sections, but it takes 5 numbers.
That's what.
4 sections, and this is only going to be used with our median. Yes. And I will tell you more specifically when we get into looking at our quartiles and our quarters, what that's going to be. And our last one, you're going to write down words that are going to feel almost foreign.
Standard.
Maybe not. Standard deviation.
Yeah, the paint is up.
You will never once have to calculate standard deviation by hand. Because we're going to do it on a computer. I'm going to show you a software. If you want to know how to compute standard deviation by hand, go take AP Stats.
No.
They don't get to use the computers for it.
No, we don't.
I'm going to show you guys a software that's going to do a lot of the calculation for us because it's more important that we know how to read and analyze than we know how to type things in a calculator. Y'all can type stuff in a calculator. It's our brain that we need to know how to use. So we're going to practice using our brain to analyze things as opposed to using our brains as a calculator because that job has been replaced. That used to be a job. A calculator. If you watched Hidden Figures, the ladies who used to basically run NASA behind the scenes, their job title was calculator. And they would be given an equation and told to double check these numbers. Please figure out where this spaceship's going to land. What's wrong with our thing? And their job was to calculate and do the numbers because calculators, the device, didn't exist yet. So that used to be a proper job. So standard deviation, it measures how far from the center with mean. And I will show this all to you again when we look at it in specific, but having this all in one page makes it easier to look at if you go, oh shoot, what does that word mean again? This is the page to look at when we go, I forget what that word is. We're making a page for that. And our last piece that we're going to talk about today is the shapes of some of our data. So we're going to take a lot of this data and we're going to make graphs or we're going to make pictures. We're going to look at pictures. We're going to read things. And there's some names for some different types of shapes.
Skew left.
We're going to talk about skew. So, yes.
Sorry, you're just used to that.
I know you are. So we could have a graph that looks like this. And what we're going to focus on right here is that this is symmetrical. You're right. It's normal.
I'm calling it normal.
Go for it. I know what you mean. We're going to go ahead and call it symmetrical. Things match. Our center will be kind of in the middle. Like things will be nice. We could have a graph that looks like this. And this is called uniform. So this would be that I had one person that gave me each answer. I asked 6 people. One person said they wanted flight. One person said they wanted teleportation. One person said they wanted super speed. One person said they wanted invisibility. Ones across the board. Universal. Like it is uniform. There is no peaks, no valleys, no nothing wild and crazy. Uniform. All right. 3 more and then I'll stop talking. So we're going to do something that looks kind of like this. Looks like the back of a camel. Bimodal. You're going to sketch these in there. So remember when we talked about mode at the top? It was our highest peak. So this would be like the mode of the symmetrical thing. It's like it's the top. A bimodal, think bicycle, has 2 wheels. Bimodal has 2 modes. So it can have 2 matching pieces, really. 2 matching modes, 2 maximums. Our last 2 are called skewed, and they can skew in different directions. Boop. Kind of looks like whales. So those are 2 different graphs. They are both skew. And we describe a skew by talking about its tail. So if the tail is on the left-hand side, this one is a skew left. Because my tail is on the left. If it's on the right, it's called skew right. And again, we will talk about these more when we start actually looking at proper data, but to be able to talk about them and have them be somewhat familiar will, I promise, help. Okay? I always think they kind of look like whales, but without the tail.
No, like high heels, like.
Yes, but then we're looking at the wrong direction. Okay? So,
If you think about it, if it's like this, you have your left foot facing the left and the right foot facing the right.
unless you stand like this.
Who stands like that?
Me. All right. So sometimes I'm also very well known for occasionally playing devil's advocate on stuff. So that's like our big vocab day. We're going to have a little bit more that we talk about as we go through. We'll have some little bits of vocab we go through. But that's kind of like our biggest of the vocab dump days.